So here we're standing outside of our tile monitoring station, and at this site we're measuring flow as well as collecting samples off of it. For flow, we have two ways that we are measuring that. First of all, at low flows we have our flume. Our flume measures flow by looking at how much water is flowing above the height of a pressure transducer. That line, you'll see a black line in the flume, is connected to a pressure system. So it's actually looking at the height of water, and since we know the dimensions of the flume and the slope of the flume, we're able to easily calculate discharge. In addition to measuring flow through the flume, we have an acoustic velocity meter. That's actually buried inside the tile, probably about 15 feet away from the end of the tile. That meter is used when we know that the tile is running at full height. So since the tile is only of a set shape, once the tile fills up, as flow increases, it gets faster. If we're only looking at gauge height, that really doesn't inform us very well as to how much water is truly flowing through that tile. That's why we tend to look at velocity instead. So in addition to flow, discharge at this site, we're also measuring or collecting samples. So this is our refrigerated sampler, and the sample line is actually buried, and it comes through this port that you can see right here. The reason why we move this port further inland is that we know at this particular location, this drainage ditch fills up under moderate flows, and the flume can easily be underwater. So we want to make sure that our samples that are being collected are as little influenced by the ditch itself, and that the samples that are being collected are truly from the tile, or truly representative of the tile. So for this station, it's powered by two independent sources of solar power. This larger array that you see here with these batteries powers our velocity meter and our refrigerated sampler. During the winter time, we obviously won't need refrigeration, but we do have a heat tape set up on our sample line. So the heat tape will be on to keep that sample line open for when we need to collect samples. The smaller array powers our bubbler system and our data logger. The data logger is essentially the brains for this entire unit. In addition to that, we also have our communications network. This site is run over a cellular network, and it enables us the ability to get our data from the station on the hour, but also provides a means for two-way communication. So that if I wanted to trigger sampling or change the pace of sampling, I'm able to do it as easily from my office, or even when I'm not in my office, from my phone. We also have 3 cameras that are installed here, and so the brains of this gauge also runs the cameras. So the cameras will take photos every hour. 2 of the cameras are on the flume. One's looking at the staff gauge, so we can easily calibrate the readings that the bubbler sensor is collecting to what is truly moving through that section of the flume. But then we're also looking at the outlet of the flume, and that really helps us, particularly during the winter time. If there's any ice buildup, we can identify when that occurs and flag that data as data that might not be correct. The 3rd camera is actually mounted on top of the station, and it's just looking at the field. And it gives us a good idea as to at what part of the growing season and what's occurring on the field at the time of the year. So we have those pictures taken every hour as well. Once the sampler starts running, a signal is sent to the cameras that also takes camera photos at a more quickened pace. So our cameras will start taking photos every 5 minutes, but then also our data collection interval will rise to a 5-minute interval. And we do that at such a short time period because we want to be able to capture these quick rises and quick falls that we anticipate to occur on a site such as this.